Let's talk about how to factor a trinomial ax squared plus bx plus c when a equals 1. In other words, x squared plus bx plus c. When you factor a trinomial like x squared plus bx plus c, you want to know what two binomials will multiply together to equal x squared plus bx plus c. Specifically, find when this equation is true, that x squared plus bx plus c is equal to x plus something times x plus something. We can use our FOIL shortcut to help us answer this question. We saw earlier that x plus m times x plus n has a final form where x squared plus the sum of m plus n times x plus the product of m times n. And we can think of it simply like this, that x squared plus the sum of the two numbers x plus the product of the two numbers. So specifically, when is this chain of reasoning true? That x squared plus bx plus c is equal to x squared plus the sum of two numbers x plus the product of those same two numbers. And those two numbers will be the numbers in our binomials that are being multiplied. To answer this question, we will always ask the question, what two numbers multiply to equal c, but add to equal b? And I put a little multiplication symbol over the c and a little addition symbol over the b to remind myself that I'm looking for two numbers that multiply to equal c, but add to equal b. Those two numbers will appear in the two binomials being multiplied. For example, factor the trinomial x squared plus 7x plus 12. We need to ask the question, what two numbers multiply to equal 12 but add to equal 7? So we look at the factor table for 12. Considering each pair of numbers, 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7, we have found our answer. 3 times 4 equals 12, but 3 plus 4 equals 7. Thus, each pair of numbers in the factor table multiplies to equal 12, but only one pair of numbers adds to 7, the numbers 3 and 4. So we can write down our factored expression that x squared plus 7x plus 12 is actually equal to x squared plus 3 plus 4x plus 3 times 4, and so our factored form is x plus 3 times x plus 4. We don't have to show the whole chain of reasoning every time. We can just write the answer. X squared plus 7x plus 12 is equal to x plus 3 times x plus 4. You can and should FOIL your answer to check to make sure that it equals the original trinomial. Another example, factor the trinomial x squared plus 11x plus 24. Again, always ask the question, what two numbers multiply to equal 24, and maybe put a little multiplication symbol over the 24 to remind you, but add to make 11, and maybe put a little plus sign over the 11 to remind you. So let's look at the factor table for 24. 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, and 4 plus 6 is 10. Therefore, 3 times 8 equals 24, and 3 plus 8 equals 11. We have found our numbers. So, each pair of numbers in the factor table multiplies to equal 24, but only one pair of numbers adds to make 11, the numbers 3 and 8. Thus, we can write down our factored expression. X squared plus 11x plus 24 is equal to x squared plus what two numbers add to make 11, but what two numbers multiply to make 24? The answer is 3 and 8, so we write down x plus 3 times x plus 8. You can and should FOIL your answer to check that it equals the original trinomial. Likewise, using this same factor table, we can see that all of these factored trinomials are also true, because 1 times 24 equals 24, and 1 plus 24 equals 25. Likewise, 2 times 12 equals 24, but 2 plus 12 equals 14. And 4 times 6 equals 24, but 4 plus 6 equals 10. Because the numbers in the binomials multiply to equal c, but add to equal b. Here's another example. Factor this trinomial, x squared minus 14x plus 24. As always, we ask the question, what two numbers multiply to equal 24, but add to equal negative 14? This is slightly more complex because we need to keep in mind that for two numbers to multiply to equal positive 24, the two numbers can either both be positive or both be negative. Look at my factor tables. Here I have both numbers positive multiplying to equal positive 24. Here I have both numbers negative multiplying to equal positive 24. Remember that a negative times a negative is a positive. So the numbers that multiply to equal 24 but add to make negative 14 are negative 2 and negative 12. Thus we can write down our factored expression x squared minus 14x plus 24 is equal to x minus 2 times x minus 12. Because negative 2 times negative 12 is equal to positive 24, but negative 2 plus negative 12 is equal to negative 14. You can and should FOIL your answer to check that it equals the original trinomial. Likewise, using these same two factor tables, we can see that all of these factored trinomials are also true, because each number multiplies to equal 24, positive 24, but they add negative 1 plus negative 24 adds up to negative 25. Negative 2 plus negative 12 adds up to negative 14. And negative 4 plus negative 6 adds to make negative 10. So all of these factored trinomials are correct. Here's another example. Factor the trinomial x squared plus 5x minus 24. As always, ask the question, what two numbers multiply to equal negative 24? And I'll put a little multiplication symbol there to remind me what two numbers multiply to equal negative 24, but add to make 5x. Well, this is slightly more complicated because we need to keep in mind that for two numbers to multiply to equal negative 24, one number must be positive and the other number must be negative. We must consider all possibilities. Consider, to equal negative 24, it could be a positive times a negative, or to equal negative 24, it could be a negative times a positive. The numbers that multiply to negative 24 but add to positive 5, therefore, are negative 3 and 8. We had to consider all of these possibilities in order to find this answer. It is so important that you have factor tables written down in front of you so that you can visually consider all the possibilities. Thus, we can write down our factored expression. X squared plus 5x minus 24 is equal to x minus 3 times x plus 8, because negative 3 times positive 8 equals negative 24, but negative 3 plus 8 is equal to positive 5. You can and should FOIL your answer to check that it equals the original trinomial. Likewise, using the factor tables for negative 24, you can see that all of these trinomials can be factored in this way. Go ahead and hit pause and study each of these trinomials to see why they're true. Look at the first one. Negative 1 times positive 24 is equal to negative 24, but negative 1 plus 24 equals 23. Go down the line and show to yourself that each of these trinomials are true and that they fit the pattern, that the end number is the product of these two numbers and the middle number is the sum of these two numbers. Clearly, there are many possible ways to use the information in factor tables to figure out how to factor a trinomial. Again, this is why it is so important to always draw out a factor table so you can look at it with your eyeballs while solving the problem. Remember to print out the factor table tool from the home page. Here's a final example so you can see exactly how to solve a problem like this. Factor the trinomial x squared minus 9x minus 36. So, I want to figure out what two numbers multiply to equal negative 36, but add to make negative 9. The first thing I will do is write a factor table for 36. To multiply to equal 36, it's 1 times 36, or 2 times 18, or, 3 times 12, or 4 times 9, or 6 times 6. However, I need to multiply to equal negative 36. So one of those numbers will be positive and one of them will be negative. The only way to use one of those pairs of numbers where one is positive and one is negative, and they'll add up to make negative 9, would be 3 and 12. The difference between 12 and 3 is 9, and so I'll make the 12 negative and I'll make the 3 positive. And that's my answer. Negative 12 times positive 3 is equal to negative 36, but negative 12 plus 3 is equal to negative 9. Therefore, I can write down my answer, x plus 3 times x minus 12. I can and should FOIL my binomials to show that it really does equal the trinomial that I want. So, first, that's x squared. Outer, that's negative 12x. Inner, that's positive 3x. And last, 3 times negative 12 is negative 36. I combine like terms in the middle, and I get x squared minus 9x minus 36, which is exactly what I started with. So it's correct. Here is a whole bunch of practice for you to use. Go ahead and use the factor table for 36. Keep in mind that if the two numbers multiply to make a positive 36, then both numbers are positive or both numbers are negative. If the two numbers multiply to make a negative 36, then one is positive and one is negative. Have fun!